Hello everyone. So this is our third lecture of module 3, and in last two lectures we have completed our concepts of function of several variables, limit, continuity, okay, and the partial derivatives, higher order partial derivatives. And the next topic is Jacobian, okay, and it is totally depending on the partial derivatives. So we have to know what is Jacobian. So today's topic is Jacobian. Suppose we have two functions. Let's say f is a function of x and y, two variable, and let g is a function of two variables. So we have two functions f and g. F is a function of x and y, and g is also function of x and y. Now Jacobian is determinant of the partial derivatives, okay, determinant of the partial derivatives. That means this is the determinant sign. So first row will be partial derivative of f, so del f del x, del f del y, okay. Similarly second row will be del g del x del g del y. Clear? Remember, in Jacobian the independent variable must be on the denominator. In fxy, which one is independent variable? X and y. Similarly in gxy, which one is independent variable? X and y. So obviously x and y, this will be on the denominator. So this is del x, okay, x variable. This is del y variable. Clear? So first row is partial derivatives of f and second row is partial derivative of g. And we denote this Jacobian by this symbol del f comma g divided by del x comma y. Or you can write in this form also, Jacobian j f comma g x comma y. You can use any one of these notations, okay. So Jacobian j is equals to del f del x del f del y, determinant of del f del x del f del y, del g del x del g del y. Clear? Suppose we have three functions, f, g, and let's say h, and f is a function of x, y, z, g is a function of x, y, z, and similarly h is a function of x, y, z. In that case, what will be our Jacobian? Jacobian will be determinant of the partial derivative. So del f del x, del f del y, del f del z. Similarly, del g del x, del g del y, del g del z, del h del x, del h del y, and del h del z. Clear? This is our Jacobian, okay. Now suppose let's solve a problem. Suppose question if x equals to r cos theta, if x equals to r cos theta, y equals to r sin theta, then show that del r comma theta by del x comma y, this is equals to 1 by r, okay. Del r comma theta by del x comma y, this is equals to 1 by r. Actually, what is this? This is Jacobian, na? This is Jacobian, but here x, y, this is on the denominator, okay, but x, y is not independent variable. Independent variable is r and theta, okay. So first of all, we have to calculate the original Jacobian. That means del x comma y by del r comma theta. So this is equals to del x del r del x del theta, del y del r del y del theta. Okay, so this is equals to, what is del x del r? This is our x na, so del x del r is equals to cos theta, del x del theta minus r sin theta. Okay, del y del r sin theta, and del y del theta r cos theta. Okay, now find out the determinant. So this is equals to r into cos square theta plus sin square theta, and so this is equals to r. Okay, but our question is, we have to show that del r comma theta divided by del x comma y, this is equals to 1 by r. So that means the inverse of this Jacobian. Okay, so del r comma theta divided by del x comma y, this is equals to 1 by del x comma y divided by del r comma theta. So this is equals to 1 by r. Proved. Okay, very simple. Let's solve another problem. Next question. Suppose if u is equals to x square minus 2y, v is equals to x plus y plus z, and w is equals to x minus 2y plus 3z. Okay, find del u v w by del x y z. Okay, so what will be the solution? Del, obviously x y z are independent variable and they are on the denominator portion, so obviously this is our original Jacobian. So del u v w divided by del x y z, this is equals to del u del x del u del y del u del z. Okay, del v del x del v del y del v del z, del w del x del w del y and del w del z. So what is del u del x? This is our u na, u is equals to x square minus 2y. So what will be del u del x? That will be 2x. Similarly del u del y, that means minus 2, and del u del z, so in u there is no variable of z, so obviously del u del z is equals to 0. Okay, now del v del x 1, del v del y 1, del v del z 1, del w del x, that will be 1, del w del y, that means minus 2, and del w del z is 3. Okay, now find out the determinant. So this is equals to 2x into 3 plus 2 plus 2 into 3 minus 1 and plus 0. So obviously this is equals to 10x plus 4. Okay, so in this way you can calculate the Jacobian, and Jacobian is very easy concept in a function of several variable. Okay, so let's come to the next topic, that is maxima minima problem. Maxima minima, this is very important concept, and definitely you will get at least one question from this topic, maxima and minima. Maxima and minima. Okay, suppose we have a function, let's say f of x comma y. Okay, we have a function f of x comma y. Now we have to find out the maximum value or the minimum value of this function in a particular region. Okay, in a particular region we have to find out the maximum value and the minimum value of this function fxy. Okay, and obviously you already know how to find out the maxima minima. First of all, we have to calculate the first derivative. Yes or no? Solving the first derivative, we will get the point. Okay, then we have to find out the second order derivative. If second order derivative is less than 0, then maxima. Second order derivative is greater than 0, then minima. Yes or no? But this concept is for single variable function. Okay, so what will be for double variable function? Concept is almost same. Okay, so first of all, f of xy, this is given. So first step is step 1. First step is you have to find out the critical points. Okay, first step is you have to find out the critical points. And what is the process of finding critical point? Calculate del f del x. Okay, del f del x equals to 0. This is equation number 1. And del f del y equals to 0. This is equation number 2. Okay, if you solve these two equations, you will get the critical point. Okay, solving these two equations, you will get critical point. Critical points. Okay, sometimes you will get more than 1 point. So critical points, remember the name critical point. Okay, critical points means the point at which the first order derivatives are 0. Okay, the points at which the first order derivatives are 0. Clear? So after solving the first order partial derivatives, you will get the critical points. Clear? Now second step. Second step is you have to find out a value at that particular critical point. Okay, the value is h. This is denoted by h. So let's say h is equals to h at the point a comma. Okay, first of all, let's calculate h x comma y, any arbitrary point x comma y. The formula is f x x at x comma y, f y y at x comma y minus f xy at x comma y whole square. Okay, or in short form you can write f xx f yy minus f xy square. This is our h. Okay, so h is equals to f xx f yy minus f xy square. What is f xx? F xx means derivative, partial derivative of f with respect to x 2 times. Similarly, fyy means partial derivative of f with respect to y 2 times. And fxy whole square, that means partial derivative of fy, partial derivative of fy with respect to x and the square. Okay, so your second step is you have to find out this h. Okay, now if h is greater than 0, okay, if h is greater than 0, where? At critical point. If h is greater than 0 at critical points, this imply extrema exist. Clear? If h is greater than 0 at critical points, then this implies extrema exists. Extrema exists means either at this critical point you will get either maxima or minima. Okay, extrema means either maxima or minima. Clear? If h is less than 0 at critical point, if h is less than 0 at critical point, this imply no extrema. no extrema. Okay, that means maxima minima does not exist. Okay, in that case, that critical point is called saddle point. Okay, in that case the critical point is called saddle point. So question is, what is saddle point? Saddle point is that critical point where extrema does not exist. Clear? Saddle point is that critical point where extrema does not exist, or in mathematically you can say that saddle point is that critical point where h is less than 0 or h is negative. Clear? Now, so this is very easy concept of saddle point. Now come to the main concept of extrema exist. So when we will get maxima and when we will get minima. Okay, if we get the result that h is positive, that means we are getting extrema. Now we have to find out this extrema is maxima or minima. So now come to the next step, that is step number 3. Step number 3. Okay, so in step number 3 we are calculating about the extrema. So obviously h is positive, yes or no? Obviously h is positive. Now we have to calculate, and h is positive where at critical points. Let's say the critical point is a comma b. Okay, a comma b is critical point. Okay, so h a comma b is greater than 0, and if f xx at a comma b is less than 0, this imply maxima. Okay, for maxima we have to satisfy two conditions. First of all, h must be positive, and the fxx at a comma b, that will be less than 0. Okay, if you want to find out fyy at a comma b, again that will be correct. Okay, fyy at a comma b, that must be less than 0. Okay, best approach is you have to follow only one process. Okay, I always follow this process, that h is positive and fxx is less than 0. Similarly, if h is positive and fxx at a comma b, again this is positive, this imply minima. Okay, so when fxx is less than 0, maxima. When fxx is greater than 0, minima. Clear? Okay, so we have 3 steps. I am repeating. We have 3 steps. First we have to calculate the critical points. Okay, first we have to calculate the critical points. Second step is we have to calculate the h. Okay, if h is greater than 0 at critical points, that will be extrema exist. Extrema exist. And if h is less than 0, this imply no extrema. And when no extrema, the point is called saddle point. Clear? And the third condition is, if h is at a comma b is positive and f xx at a comma b is again positive, this imply minima. Okay, and h at a comma b, this is greater than 0, and f xx at a comma b, this is less than 0, this imply maxima. Clear? So this is the whole concept of maxima and minima problem. Okay, so let's solve a problem. Question: find the maxima and minima of the function x cube plus y cube minus 3x minus 12y plus 20. Okay, find also the saddle point. Find also the saddle point. Solution. So first step is we have to find out the critical points. Okay, so here f of xy, here f of x comma y, this is equals to x cube plus y cube minus 3x minus 12y plus 20. Okay, so del f del x equals to 0. This implies, what is del f del x? 3x square minus 3 equals to 0. Okay, 3x square minus 3, this is equals to 0. That means we are getting x square minus 1, this is equals to 0. Okay, now del f del y, this is equals to 0. This implies 3y square minus 12 equals to 0, and this implies y square minus 4, this is equals to 0. Okay, if I solve the first equation, equation number 1, and this is equation number 2. If I solve the first equation, x is equals to, you can write solving 1, x is equals to plus minus 1, and solving 2, y is equals to plus minus 2. That means we have 4 critical points. So the critical points are, what are those critical points? First 1 comma 2, okay, second 1 comma minus 2, third minus 1 comma plus 2, and the last one minus 1 comma minus 2. Clear? These are the critical points. Now we have to find out h, and to find out the h, we need fxx, fyy, and fxy. So first of all, let's calculate fxx. What is fxx? Fxx means partial derivative of fx with respect to x. So this is our fx now, 3x square minus 3. So what will be fxx? 6x, yes or no? 6x. So fxx is equals to 6x into fyy. Next one is fyy. So what is fyy? This is our fy. So fyy will be 6y, and fxy. Fxy means partial derivative of fy with respect to x. So this is our fy, 3y square minus 12, and partial derivative with respect to x, that will be 0. So fxy is equals to 0. So h is equals to fxx into fyy minus fxy square. So this is equals to 6x into 6y minus 0. So we are getting 36xy. Okay, so we already have gotten the value of h. Now we have to find out the conditions at that particular critical points. First we are calculating for 1 comma 2. So at 1 comma 2, at 1 comma 2. So at 1 comma 2, what is our h? H is equals to 36 into 1 into 2. So obviously this is positive. We need not the value of h. We need only it is positive or negative. So h is positive. So obviously at 1 comma 2, extrema exists. Extrema exists. Okay, now calculate fxx at 1 comma 2. What is fxx? 6x. So 6 into 1 na 6x, so this is 6. That means it is positive, and positive means minima exist. Clear? Positive when fxx is positive, that means we are getting the minima. So it implies that the point 1 comma 2 is minima. Okay, that means at 1 comma 2 we will get the minimum value of the function. So what will be the minimum value of the function? Minimum value, this is equals to, that means we have to put x equals to 1 and y equals to 2 in the given function. What was the given function? X cube plus y cube minus 3x minus 12y plus 20. So x cube, that means 1 cube plus 2 cube minus 3 into 1 minus 12 into 2 plus 20. So this is equals to 1 plus 8 minus 3 minus 24 plus 20, and this is equals to, what is the value? So this is equals to 2 na. 20 minus 24 minus 4 minus 4 minus 3 minus 7 plus 8, that means plus 1 plus 1 plus 1 plus 2. So at 1 comma 2 we are getting the minimum value, and that minimum value is 2. Okay, now next calculate for the another critical point 1 comma minus 2. So at 1 comma minus 2. So at 1 comma minus 2, what is the value of h? H is 6xy na. H is equals to just a minute, 36xy. 36xy. So this will be 36 into 1 into minus 2. So obviously this value is negative, and when h is negative we know that no extrema, and this imply 1 comma minus 2 is a saddle point. Clear? Because at 1 comma minus 2 we are getting no extrema result, so 1 comma minus 2 is a saddle point. Next calculate for the second point. Second point is a third point, minus 1 comma 2. So at minus 1 comma 2. So at minus 1 comma 2, what is our h? Minus 1 comma 2. So 36 into minus 1 into 2. Obviously again this is less than 0, and less than 0 means no extrema. Okay, and this imply minus 1 comma 2 is a saddle point. Okay, and the last one at minus 1 minus 2. Yes, minus 1 minus 2. So at minus 1 minus 2, what is our h? 36 into minus 1 into minus 2, and minus minus plus, so obviously this is positive, and positive means extrema exist. Okay, so what will be the value of fxx at minus 1 minus 2? Fxx is equals to 6x. So 6 into minus 1, that means minus 6, obviously less than 0, and less than 0 means maxima. Okay, and maxima means this point minus 1 comma minus 2, this point is maxima, and at that point you will get the maximum value. So what will be the maximum value? Maximum value is equals to put x equals to minus 1 and y is equals to minus 2 in the given function. Okay, so minus 1 whole cube plus minus 2 whole cube minus 3 into minus 1 minus 12 into minus 2 plus 20. So this is equals to minus 1 minus 8 plus 3 plus 24 plus 20, and this is equals to, what is the value? This is equals to 38. 20 plus 24, 44, 47 and minus 9. Okay, clear na? So this is equals to 38. So now finally, what are the maxima point? Maxima point is minus 1 comma 2, minima point is 1 plus 1 comma 2, and maximum value is 38. Minimum value, what is minimum value? Minimum value is 2. Okay, and what are the saddle points? Saddle points are minus 1 comma 2 and minus, and the second one is 1 comma minus 2. Okay, so in this way you can solve all the maxima minima problem, and definitely you will get at least one question from this topic. Okay, so now you can solve the question bank problems, or you can solve the textbook problems, and if you have any doubts from this topic, you can ask me on my WhatsApp number. Thank you.